Hello students, this is Anjanelu Physics faculty. Today I am going to explain wave motion, important chapter for LAQs and as well as important for competitive level also. So first part here I am explaining stationary waves. So first what is stationary wave? Stationary wave, so it is a two sound waves superimposing to each other, so resultant wave forming on the strings and in the organ pipes, those are all called stationary waves. So basically stationary wave today I am explaining on strings how these are waves are forming, and later I will explain how these waves are forming in open pipe and closed pipe. Right. Stationary wave. Stationary wave or this type of waves are also called standing wave. So when two sound waves of same frequency, same amplitude and same wavelength, these waves are passing along the string and in opposite direction, get reflecting back from the rigid support. These two waves are superimposing to each other. After reflecting back, stationary waves are forming on a string. So let us suppose if I is taking a string and the string fixed between the two rigid supports, and a vibrating tuning fork is placed just a little bit above the string, the wave is passing to the string and this wave reflecting back from the rigid support. After the rigid support, reflecting wave rigid support, this wave and initial wave both are superimposing to each other, stationary wave forming on the string which is fixed between the two rigid support. See, this one simple thing I am explaining by using a diagram here. First I am taking here one string and it is fixed between the two rigid supports. So what I told here, one vibrating tuning fork taking here, from the vibrating tuning fork this wave passing like this here, passing and reflecting back. See, after this one, this wave reflecting back from the rigid support, this wave passing like this way, and both are superimposing to each other. This type of waves are called stationary or standing wave. The main difference between stationary wave and a traveling wave equation, in a traveling wave equation, the energy and momentum is transferring through the medium, but in the stationary wave, energy and momentum not transferring. The energy distributed between only 2 points. Those 2 points are called node. Later I will explain what is a node and what is antinode. So it means clearly energy not transferring through the medium in case of stationary waves. So first here two waves I told here. One is incident wave, second one is the reflecting wave. And we know traveling wave equation displacement. Right, so that equation I am taking now. Displacement of traveling wave equation, y of x comma t is equal to, it is a sine omega t minus k into x, this one. So in this equation, omega representing angular frequency and k is the propagation constant. Suppose if the wave traveling along positive x direction, we should take here negative sign. That's why I wrote here minus, and this y of x comma t representing the displacement of particle along y direction, and x representing the wave moving along the x direction at any instant of time t calculated here. So finally what is y of x comma t means the displacement of particle along y direction, wave moving along x direction at a time t second calculated here, right. Now this one I am taking here y1, after this wave reflecting back from the rigid support. Now the displacement y2 is equal, simply I am writing here y2, which is a sine omega t minus k into minus x. Why we are taking again one minus for x means after reflecting back the wave moving along negative x direction. So I wrote here minus sign. So here minus of minus we can write positive here. So therefore displacement y2 is equal to, it is a sine omega t plus k into x. But according to principle of superposition, the two waves are superimposed to each other. So therefore, so the resultant wave displacement y is equal to sum of the displacements of two waves. So it is y is equal to y1 plus y2 I am taking here. The y is equal to y1 plus y2. So after substituting these two values in this equation y1 and y2, so directly I am taking common a sine omega t minus kx plus, so sine omega t plus kx I am taking here. Right. Next, here applying here sine c plus sine d or sine a minus b sine a plus b are applying here. So the resultant displacement equation I am writing here, that is y is equal to 2a sine kx cos omega t. This is cos omega t. So again this equation we can write that resultant wave displacement y is equal to a suffix r into cos of omega t. So where a suffix r representing the resultant wave amplitude. That resultant wave amplitude is equal to, so 2a sine k into x. This is important equation, and here already I told k is the propagation constant. The k is equal to here what we can take 2 pi by lambda, where lambda is the wavelength. Okay, right. Next, in this equation, suppose if I am taking x is equal to 0, lambda by 2, 2 lambda by 2, 3 lambda by 2 and so on. So resultant amplitude is equal to, you will get 0, because sin x 0 into k 0, sin 0 0. Again 0 into 2a is equal to 0. That's why resultant amplitude 0. Not only this point, so for all these positions like lambda by 2, 2 lambda by 2 and so on, resultant wave amplitude is equal to 0. So on this wave, where the resultant amplitude 0, those all positions are called node. It means if observing this diagram, here amplitude 0, that's why this is node, here also node, this point and so on, this is also node. So it means clearly on the stationary or standing wave, where the resultant wave displacement we got 0, those all positions are called node. So I am writing that only here, these positions are called nodes. Next, at the same time, if I am taking in this equation x is equal to, so lambda by 4, 3 lambda by 4 and so on, all odd number, all the multiplying of lambda by 4, for all these positions resultant displacement is equal to 2a. It means this is the maximum value. Amplitude where we are getting maximum on the resultant wave, those positions are called antinode. Already node discussed, now amplitude is maximum, those positions are called antinode. See, I am mentioning in this diagram here, so here antinode because amplitude maximum, here antinode, here, these all positions are called antinode. Right. Next, so one wavelength means here on a stationary wave, one positive half cycle and one negative half cycle is called one wave. It means in this diagram, so I am taking from here to here. This is node positive half cycle, this is one negative half cycle. From here to here, it is called wavelength lambda denoting this one. So it means clearly it is a node, we know, this point also node. So any two adjacent node is equal lambda by 2, and a node to antinode position half of lambda by 2, which is called lambda by 4. So those important points I am writing now here. So distance between two adjacent node is equal to lambda by 2, and a node to antinode is equal to lambda by 4.